Let's get going. So what I will talk today about is Kubernetes, of course, is Kubernetes Community Days, but specifically about validating admission policies that were introduced a few versions ago as alpha. It is graduating now to beta. We are going towards GA, so it will be available in all Kubernetes clusters out of the box, not so far from now. Now, quick introduction. This is me. I'm Victor. I work for Upbound. I have a Twitter account. I belong to some groups. I have some books and podcasts and YouTube and what's not. Not important. What does matter is jumping straight into the subject. So, before I explain what validating policies are, I need to explain how admission controllers in Kubernetes work. They are a critical part, not only for what I'm talking about now, but in general. If you want to use Kubernetes one way or another, you need to understand how admission controllers work. That's basically the engine behind the API, and in Kubernetes, API is absolutely everything. So, admission controllers, right? When we send where was I? Oh, I jumped somewhere else. There we go. When we send a request to Kubernetes with kubectl or Helm or Customize or whatever we're using, what we are essentially doing is sending a request with the desired state, which is your YAML files. Even if you're using Helm, it still goes as YAML to API or JSON. And when we send that request, typically people think, okay, so I sent a request, create this deployment or manage this deployment, that's about it. But a lot of things are happening between Kubernetes receiving a request and until something is up and running in our cluster. And I will not go through all the stages of everything that is happening, just those that are really important for this story. And the first thing that happens when we send a manifest to Kubernetes is that it goes through role-based access control or RBAC, and it is validating whether the person or the machine that sent that request is authorized to do whatever that request contains, right? That can be many, many different things, but generally it is split into cluster-wide, creation of cluster-wide resources and namespace scoped resources and so on and so forth. I will not go into details. What does matter is that we are validating whether we or it can do whatever the request contains and instructs Kubernetes to do. Now comes the interesting part, right? After we are authenticated, it goes through the first admission controller, which is mutations. Now, mutations are something that you might not know it's happening, but it's actually used heavily in Kubernetes. And a good example of mutation is service mesh, right? When we create deployments, which create replica sets, which create pods, and pods contain containers, and if you're having service mesh, let's say East or Linkerd or something like that, mutation controllers are kicking in by adding sidecar containers to pods, right? It is modifying, the purpose of mutations is to modify what we said that we want to accomplish some additional features. In this case, on this diagram with service mesh, it could be many, many things. We could use, and service mesh, by the way, it's a third-party component. You don't even know that it is doing mutations, that it is modifying something before that something becomes something real. Or we can use something like Verno, which we could use to instruct Kubernetes that, hey, for example, whenever somebody creates a pod, and if that pod does not contain the amount of resources that should be assigned to that pod, like requests and limits, modify the manifest and add some default values like, hey, by default, if nobody specifies where this application is going to use 1 CPU and 2 gigabytes of memory or whatever. The point is that with mutations, we modify the resources before they are applied to the cluster. And those modifications are applied directly on those resources before they are committed to the internal database, which I will get to soon. And then we have object schema validation, which essentially means that after the modifications happen, Kubernetes will validate whether that resource, modified or not, complies to the schema, right? Every single object in Kubernetes has a schema. Some of those objects or resources, or resource definitions to be more precise, are baked into Kubernetes, like deployment, services, and so on and so forth. Some are some schemas are created by extending Kubernetes with custom resource definitions. For example, if we want to run Postgres database in Kubernetes, you might choose to use CMPG or Cloud Native Postgres, which will create a new resource type, new object. Anyways, the point is that it is validated whether the resource, that mutated resource, complies to the schema of that specific resource definition. And Kubernetes either says it's okay, you can proceed, or no, you're not complying with the schema. Great. Now comes the important part. And that's, at least for this subject, right? And that's admission controllers validations. That's the point in time when we can create certain validations and validate whether that something is acceptable, right? Because the fact that some resource passes schema validation does not mean that it is valid, right? You might say validation could be, hey, you must specify the amount of CPU and memory, but you cannot have more than 4 gigabytes of RAM and 8 CPUs in this namespace, right? That's where we validate whether something is okay or not. And it is our responsibilities as administrators of the cluster to create those validations, and I will show those later. Anyways, if it's valid, it can proceed, and only that then the data is stored into etcd, which is internal Kubernetes database essentially, and only after it is stored and committed to etcd or whatever you might be using, the resources are created, right? That's when pods end up in your cluster or deployments or Postgres or whatever we are using, right? Now, this part of admission controllers validations, that's just a trigger or a webhook in Kubernetes. Out of the box, it does nothing, right? Or at least it wasn't doing anything until few versions ago when validating policies were introduced, right? So validating policies came half a year ago. Still, now it is in beta. Soon it will be part of every Kubernetes cluster. And the question is, what is it, right? And the simple answer to that is that it is policies just like Kyverno or OPA or whatever you might be using for your policies today, except that they are now baked or soon will be baked into Kubernetes, right? So it is a policy engine that will come and be available to every single Kubernetes cluster. And here is one example, right? It's a very, very simple one that says, hey, I'm defining a policy, cool. And I'm saying that if something doesn't comply with this policy, it should fail. It could be also informative. Further on, I'm specifying that this policy should apply only to APIs apps version 1, and only if I create or update, meaning that it will not apply if I try to delete some resource. And within that scope, it applies only to deployments. And then we have expression that says, hey, a deployment is valid only if spec replicas is smaller than or equal to 5. Meaning that if we apply this policy, whomever specifies more than 5 replicas will be denied creation of that resource or update of that resource, right? So policies, it must be less than or equal than 5 replicas. A very simple one, right? I'm not doing anything complex here. Now, policy like this by itself is not doing anything. It's just a definition. It's just an entry in etcd, nothing else. What we need to do is bind it to something. And in this case, I'm defining policy binding that says, okay, that policy that I showed before, the one that is called demo policy, that one will be applied only and exclusively to the namespaces that have the label environment set to test. So if you try to create a deployment that is not in a namespace that has environment set to test, policies do not apply. But if that namespace does have that label, then it does, right? And there can be other ways how we can define which resources are validated through those policies. In this case, through namespace labels. Now, all that looks very easy, right? There's not much to do. Define policy and define when does that policy apply, right? What does it bind to? Extremely easy. Except that it doesn't work, right? It doesn't work in serious Kubernetes clusters, right? And it doesn't work for quite a few reasons. And so let's go through those reasons. Let me explain why something so simple as what I showed you doesn't work. And to understand why it doesn't work, we need to understand what is an application in Kubernetes, right? If I will now, let me switch to my terminal. I will deploy an application, a simple one, right? There we go. Nothing really special. I created a config map for Postgres database, a secret, a couple of services, a deployment for my application, stateful set for Postgres and Ingress, right? It's a very, very simple application with the database. Nothing really special. Now, if I, let me actually move this to a different screen. There we go. If I list what I have in that namespace called production, you will see that I have all those things. Now, this is the simplest, one of the simplest possible applications I could come up with. And you can see already that it has a bunch of things. There is no such a thing as application in Kubernetes. Such a thing does not exist. We have different low-level components, let's say building blocks, that only when they're joined together, we get an application, right? And in this case, we are creating some services and the deployment. Deployment creates replica set creates pods. We have stateful set for the database, couple of config maps, a secret with the authentication through the database and Ingress, how we can access that application, right? Extremely simple one, yet already far from simple, at least when compared to before Kubernetes, right? So what we're doing as developers, and when I say developers, any engineer, right, is that we instruct Kubernetes to create a bunch of things, different low-level components, and they are doing something when joined together, right? They have a meaning only when they're grouped together. Individually, they do not represent anything tangible, really. Now, let me destroy this application and move to something from this was easy, and it still is, to something slightly more complicated, but more realistic, right? So, what happens if we extend our Kubernetes cluster? And everybody is extending Kubernetes cluster. What happens if we add Argo CD, for example, or we add Knative, which is absolutely amazing project for converting your cluster into an engine to run serverless applications, right? Or Crossplane, which is the project with which I work right now. Now, what is happening if we add those projects is that we are extending Kubernetes. Almost everything in Kubernetes is extending it somehow, right? And I can show those extensions by listing all CRDs. And you can see that those are all the types of resources that I have in my local cluster. I'm not even doing real production here, that are extensions of what I can do with my Kubernetes cluster, right? There are a couple of hundreds of those. And again, I'm not doing anything really complicated. So what is happening really is that Kubernetes is becoming a control plane, meaning that, and that actually Kubernetes was always a control plane, right? It controls stuff. Now, what is happening right now is that it is becoming a control plane not only for resources running in Kubernetes itself, not only for containers, but for everything else, right? When you create an ingress so that your application is accessible from outside, what is happening? Your Kubernetes cluster is controlling resources outside of the cluster. It is creating a load balancer in AWS or Azure or Google, wherever you're using it, right? If you use something like KubeVirt, your Kubernetes cluster will be managing virtual machines. If you attach storage, your Kubernetes cluster is managing storage that is outside of the cluster and attaching it to the nodes of the cluster. And in case of Crossplane, that extension becomes even bigger, right? Because with Crossplane, we can manage anything we want. What matters here is that Kubernetes is a control plane that manages things, whatever those things are, and those things can be anything: virtual machines, WASM, containers, cloud resources, anything, right? And that means that two things are happening. First is that only machines can manage Kubernetes clusters. Humans are too slow to do that, right? That's why we have GitHub, that's why we have pipelines, and so on and so forth. Nevertheless, we are capable now of extending Kubernetes cluster to manage different types of resources, and the number of resource types that we can manage drastically increases, right? Now, if I go back to the previous question about policies, how easy or hard it is to define policies? The answer is, what is the answer? The answer is, it all depends on the context, right? The example I showed about policies was about, hey, how can we ensure that people do not, or machines do not specify more replicas of an application than what we can handle? Maximum is 5, right? But that is almost useless without the context. So the previous example, actually modification of the previous example, right, would be like this. Hey, you cannot have more than 5 replicas. And since there are different entities that can manage replicas in Kubernetes cluster, I extended it by saying, hey, this policy applies to both deployments and stateful sets. Now, the problem with all this is what happens if somebody introduces tomorrow horizontal pod autoscaler, right? That's a type of resource that will automatically scale the number of my pods by automatically modifying deployments or stateful sets without really anybody specifying the number of replicas, right? And we cannot define policies for a single policy that will verify whether deployments or stateful sets or horizontal pod autoscalers are not passing 5 replicas in this example for a simple reason, because admission controllers in Kubernetes are working on a single resource base, meaning that each resource, like deployment, stateful set, service, ingress, is evaluated in isolation, right? So Kubernetes does not have the idea about the context of your application, does not receive at the same time all the information it needs. It does not get at the same time both deployments and services and ingresses and horizontal pod autoscalers and vertical pod autoscalers, right? They're all evaluated one by one because that's how API works. So what should we do? How can we fix that, right? Now, the problem with this whole story and the difficulty of managing policies is in big part based on sorry, I was looking at the comments, based on custom resource definitions. We're extending Kubernetes clusters, and through those extensions, having the drastically increased number of resources that we need to manage, and all the permutations between all those resources make policies almost impossible to manage, right? Now, one example of that extension can be, as I mentioned before, hey, we can bring Argo CD that will create new custom resource definitions that will allow us to create new custom resources ourselves, and that will increase the complexity. But we can also at the same time use those custom resource definitions to decrease the complexity. We can say, hey, instead of let me find, where was my diagram, right? Instead of doing all this for a single application, we can create something like this. We can create our custom resource definition that says, hey, you do not need to worry. You're not even allowed to work with ingresses and deployments and pods and replicas and horizontal pod autoscalers and all that madness, you can create your own definition, or you can use the definition that I will create for you, how to create applications, and I'm going to call this upclaim, right? This is my custom, does not come out of the box. This is how you create applications. You can use labels to select what type of application you want. You can specify a couple of parameters. There is a single resource, not 57 of them, and then the heavy processing will be happening inside of the cluster. So we get some picture like this, right? Instead of managing each of those individual resources separately and creating policies that do not understand the context of the existence of the other resources and killing ourselves with the number of permutations, we can create a new resource definition and define custom resources, and let's say have something called application, right? Or a database, or whatever that something is. And then API will validate that single resource and make sure that it is valid, that it complies with whatever stuff we want it to comply with. And then creation of the low-level resources will be happening in a cluster, right? Now, I will use for that Crossplane. Just as example, I'm not selling you Crossplane today. I'm just going to use it as example for you to see how all that looks like, right? So I will create something defined in a file, AWS official. I will show soon what that something is. What does matter is that the result of me creating that single YAML, I got all those things, right? I got some objects in Kubernetes cluster and a database in AWS and security groups and security rules and route tables and all the stuff that I need to operate, in this case, a database successfully, right? Now, if somebody would try to create policies that would prevent me from doing stupid things based on all those resources, that somebody would never finish, right? Because you would need to create policies for VPCs, for subnet groups, internet gateway, and more importantly, all the variations and permutations of all those combinations that could occur, right? Which is insanely big. Now, so one option, where was I? Here we go. One option is to create policies for each of those resources, right? Which is never going to happen. What we can do is say, you know what? I will do two things. I will deny access to anybody for all those low-level resources. So you cannot directly work with the DB server, with VPC, with security groups, subnets, route tables, whatever you're working on. You can work on a higher level resources, like in this case, something called SQL, right? Because my example is with a database, it could be anything else you want, application, queue, anything, right? And that will greatly simplify how policies work. So let me show you one example, right? So this is what I just created a second ago, right? I said I want SQL claim. This is a custom resource definition. I'm using labels to define where will I create the database, in this case in AWS, and it will be Postgres, and I want Postgres 13.4, and I want small nodes, right? But what matters is that I could also define, that would be the user developer, right? I as administrator, I can define policies now finally, right? I can say I will have one policy that will say that whenever spec parameter size is small, medium, or large, it's okay. If you put any other value, you will be denied access to the cluster, right? And that will apply to something called SQL claim or SQL whenever we create or update. And then I'm going to create a policy binding that says, hey, this policy that I mentioned before will be used only if used on namespaces that have the label environment that is not set to silly. So meaning this policy applies to every single namespace unless the value environment is something else than silly. And another policy, same one, hey, the nodes Node sizes can be medium or large. It cannot be small. These are the versions of Postgres that you can use, and I will apply this to production, right? Production is special. It is production. We want to have special rules for them, right? And now what happens if I do that? I will apply that policy. I created those 4 policies. And now what I will try to do is to apply the same definition that I showed before that created the database ultimately, my AWS account. I will try to apply it again, right? Now, the only difference between what I did before and now is that now I'm applying this definition to a namespace called production2 that has the label production, right? And Kubernetes immediately kicked in and says, hey, you cannot do that. You have something called SQL claim, and it is validating the policy that says that the size must be medium or large. You did not specify it to be medium or large. You specified it to be something else. And that something else is where we are. Here we go, right? I said it can be small, right? Now, the only way for me to solve this now would be if I modify this manifest, vim, there we go. Okay. Administrator says, the policy says it cannot be small. Let me make it medium. There we go. Let me apply it again, and now it works, right? It is safeguarding us, not by creating policies on every single resource separately, which would never happen, but by denying people to use low-level resources, putting them on the higher abstraction level, and then creating policies for those abstractions. And I'm trying to be within my allocated half an hour, so I think I'm just on time. Thank you for listening. And if you have any questions, I believe I have 5 minutes for questions, so shoot.
So I have a question, and actually it's kind of obvious. I believe that since this is on a mission controller or a sort of a mission controller what we're talking about, it means that it only manipulates whatever it gets applied. It doesn't manipulate anything that already exists. Is that correct?
Yes, that is correct. So it works from the moment you create policy, it works, right? It doesn't work retroactively for the resources that existed before they were created until the next time you modify them in any form or way.
Yeah, makes total sense. Actually, I enjoy a lot this conversation that we have today because as a platform engineer or a Kubernetes administrator, the first thing that comes into your mind is to, hey, I don't want to manage a lot of YAMLs, just keep the access to the developers. But then you have the problem. Maybe a developer is going to change something that they shouldn't, and there comes a problem.
Yeah, there are 2 problems there to begin with, I believe. First is you cannot give direct access to developers not only for security reasons, but simply because majority of people do not have 7 years time to spend to learn Kubernetes, right? What is service mesh? What is how storage works? What is pod? What is replica set? What is deployment? And all that stuff, right? It is too low level for us to expect that everybody will learn it because it will not happen in a day. It's not as easy as Docker, right? It is much more powerful and much more complicated, right? So the first of the 2 things I believe is that we need to create abstractions so that you can say, okay, what matters to you? What do you care about when deploying, let's say, an application, right? Oh, you want to know whether it's backend or frontend, what is the host and stuff like that. And then you can create that interface for them, right? Simplify it so that people can use it directly instead of asking you to do it for them. Once you simplify it, and that's through custom resource definitions in Kubernetes, then at the same time you get easier way to create policies, because then you're creating policies only for those resources that are higher level, and you don't really need to care about low level resources like pods.
Yeah, I hear you. So it's a way to create another abstraction, a more simple abstraction over Kubernetes, so that we provide that CRD to the developers. The developers only need to learn about that CRD, and that is all. And the other thing I was thinking about is that the user, the developer is going to use in order to access to the cluster, only needs to have the policy, the role binding for that specific CRD instead of everything else.
Exactly, exactly. Because it's the same thing like when you go to AWS, you have access to EC2. You don't have access to something low level like hypervisor, right? AWS never gives you access to hypervisors because you don't need hypervisors. You need abstractions on top of hypervisors, which is EC2, right? Same thing for in this case, right? You don't realistically need access if you do the things right to everything in Kubernetes. You need access to the abstractions that enable you to do whatever you need to do, and then the creation of those low-level resources is happening in the cluster, not on your laptop.
Okay, I love it. I'm may going to apply it next week. No, I'm kidding. But I'm going to apply it as soon as I can. So I don't know if you have another thought to share over here, or I see you have the DevOps toolkit YouTube. So
Yeah, you could check the YouTube channel. I mean, I do a lot. Almost everything I do is in public. There is a podcast, DevOps Paradox. I probably have a slide somewhere. There we go. Check this one out as well. I speak. I travel a lot, so I speak in a lot of conferences. I contribute to a lot of projects, so on and so forth. Right. Everything I do is public. Just search for my name.
yeah, everybody was excited about your name over here. It's like, oh my God, it's going to be in KCD Guatemala. I need to be there. By the way, I'm just checking the chat within the platform, and I believe that everybody is shy right now because it's too early in the morning, or maybe.
Come on, it's not Norway. They're shy in Norway. Latin people are not shy. What's happening here?
Sometimes they get shy because we are speaking in English. And by the way, hey, pueden preguntar en español, con mucho gusto aquí les ayudo. Y Víctor me dijo que también habla español.
Sí, podéis preguntar en inglés, en español, en catalán y en serbio.
Super,
Podéis elegir entre estos cuatro.
Vamos a ver acá. Fíjate que no veo más preguntas, pero ¿qué fue lo más difícil? And actually you can switch back to the English if you want to. What is the most difficult thing about implementing this policy abstraction?
It's not really difficult. It's extremely easy. The difficult part is really understanding Kubernetes. It looks like, hey, I spent a week until I understand it, but understanding Kubernetes itself is the difficult part, right? Once you do understand how Kubernetes really, really work, and when I say that, I don't mean, hey, I know how to create a pod, right? I mean how Kubernetes itself really works, then everything else is easy because that's a beauty, I think, of Kubernetes and the extensible API. What's to notice that every project, no matter whether it is baked into Kubernetes or it's outside, like Caverno, Argo CD, Flux, Prometheus, anything, right? Anything follows that logic. Every Kubernetes native project, and there are a lot of them, are really applying the logic of Kubernetes itself. So once you figure out how Kubernetes works, everything is really, really easy, at least to understand.
Okay, so that's the catch. You have to be at least at Kubernetes administrator level so that you understand all the abstractions, and then you can work on the policy.
Yes.
Otherwise, it's going to be kind of difficult.
Exactly. Then it's easy.
Okay, I don't see any more questions over here. So anything else that you want to share?
No, just as I said, everything I do is in public, so any of you is free to ping me anytime if you need help or I can do something to help out or just talk or whatever. Just ping me somewhere, Twitter, LinkedIn, GitHub, whatever. I'll do my best.